All right, we're about to enjoy example 4.1 underneath differentials. And so here's the deal. We're talking about, we have a square and it has changed. All right, and we'll get into the details of that in a minute. But this talks about the area of a square. So in general, if we were to draw a square, its dimensions would be x by x, wouldn't it? So in general, isn't the formula for the area of a square x squared? All right? Let's call it A for area. So the area is x squared. Now, here's what's happening specifically. That's in general. Specifically, we have a square that is 10 by 10, and we have another square that is a smaller one, and I'm exaggerating that it shrunk, honey, I shrank the square, I don't know, honey, I shrunk the square. But anyway, this square has changed from here to here, all right? And the question is how much change in area was there? I'll be the first to acknowledge, you could figure the area of this one, the area of this one, subtract them and get that change. I get it, that wouldn't be that hard. But if we're gonna use calculus here, here's the idea behind it. We're gonna use a differential to do that. And so, the idea behind that would be if we take this generic formula for the area of a square and differentiate it, find the derivative, and I'm thinking with respect to x, all right? So if we differentiate with respect to x, this is gonna be dA dx, just like dy dx, right? Different letter, but same principle. And then over here, that would be 2x, wouldn't it? dx dx, which is 1. All right? That would be akin to the dy dx equals f prime of x. That's a derivative, but a differential. See, they wanted to know how much change in area was there. And symbolically, that's dA, the change in area. So the idea would be, let's solve this for dA by multiplying both sides by dx. And so we get the idea that the change in area would be equal to 2x dx. All right? So now, the specifics of this question, we would simply say, if we want to know the change in area from this square to this square, we would just simply go, okay, when you apply that to this picture over here, you would have 2 times, let's see, what was the original value of x? 10, the beginning square, the one it started with, and then dx would be how much change was there in the x. And didn't this go down by 0.2? So that would be a negative 0.2. Everybody see that? The change in x. The change in x. We went from 10 to 9.8. It went down by 0.2. And then my brain is not working great, so I'm going to put that in the calculator. 2 times 10 times negative 0.2 is negative 4. So the idea is that the change in area from here to here was negative. It went down, right? 4. And then what do we put here? Were there units of measurement on this thing? Darn it, I should have looked. Yes, it was inches. All right. So didn't it go down by, and it's an area, so wouldn't that be square inches, which I like to write as inches squared. So that's the change in area from this one to that one. That's dA in the language of calculus, in the symbols of calculus. Cool.